Section 6.3, example 3 on page 442, we have when you have a sum or difference of radical expressions, you should simplify each expression so that you can find all the like radicals. Example 3 says, what is the simplest form of the expression, the square root of 12 plus the square root of 75 minus the square root of 3? These are all square roots, meaning they all have an index of 2. However, right now, all the radicands are different. So here we have 12, here we have 75, and here we have 3. 12 is not a prime number, so we can definitely create a factor tree for it. 75 can also be factored. 3, however, is prime, so there's not going to be any changing 3. So we really just need to focus on 12 and 75. I started by making a factor tree for 12. We have 3 times 4, where 3 is prime. You can break 4 down into 2 times 2, so we have 3 times 2 times 2. So I rewrote the square root of 12 as the square root of 3 times 2 times 2. And we have a square root, so we're looking for doubles, 2 of a kind. There are 2 2s, so I went ahead and highlighted those. I did the same thing for 75. 75 is 3 times 25. 3 is prime. 25 is 5 times 5, where 5 and 5 are prime. So instead of writing plus the square root of 75, I wrote plus the square root of 3 times 5 times 5. Again, we're looking for doubles. I found 2 5s, so I highlighted them. And then I just brought down my minus radical 3 because 3 is already prime. All I've done now is take my square root of 3 times 2 times 2 and taken the double, or the squared term, the 2 squared, into its own radical. So now I have the square root of 2 squared times the square root of 3, all still together. Then we have our plus sign. I did the same thing with the 75 radical. So instead of 3 times 5 times 5, I now have the square root of 5 squared times the square root of 3, still all together before the minus sign. And then we just bring down our minus radical 3. The square root of 2 squared is just 2, so now we have 2 radical 3, plus the square root of 5 squared is just 5, so this becomes 5 radical 3, and then we have minus radical 3. So notice, now we have a square root, square root, square root. They all have an index of 2, and we have 3, 3, and 3, so the radicands are all the same now. Once you verify that the index and the radicand matches in each expression, we can look at just the number out front and combine them. This last one was just the square root of 3. If it helps, you can throw that 1 in front of the square root because it is 1 square root of 3, so you're allowed to write the 1 if that helps you. We have 2 square roots of 3 plus 5 more will give us 7 square roots of 3, and then we're subtracting 1 square root of 3, so 7 minus 1 will give us 6 square roots of 3. This is going to be the simplest form. Now, the factor trees are extra explanation for me to make it as clear as possible in the video. This part right here, separating it out a bunch of times, rewriting both of these steps may be too much work for you. You might be able to do some of this in your head, and that is totally okay. As long as you are showing some of your work so that I can see that you know what you're doing, you're good to go. The work for this problem is written out on the next few slides. And now I would like you to try number 4, simplify the cube root of 54 plus the cube root of 16.